Female behavior is dependent on food and nutrition. Male behavior is dependent on females. And so it's the females that sort of set the stage and create the potential for males to be polygynous, or the fact that they can really only be monogamous.
You've spent many decades in the jungles studying these animals. Have you witnessed that with your own eyes?
Seeing an infant die as it struggles and struggles day after day, that's painful. That's hard.
Dr. Robert Seyfarth, welcome to the channel. I'm so excited for this. We are ranking 9 different animal groups by the complexity of their political system, their societal structure. Really, really excited for this. Let me click random number and we will kick off. Okay, first one is 4. So corvids, interestingly. So maybe start off by explaining what is a corvid.
A corvid is a group of birds. Most familiar to everyone are crows and ravens, but also jays, and they have very complex society. And in fact, in some ways, one of the best ways to describe this is that for a long time, we really didn't know very much about crow society in, say, North America, because the crows would often disappear and they would be really hard to catch and mark, so that you had difficulty keeping track of individuals. And but there's been some really wonderful work on crows foraging in Vermont, and they do seem to have a society that is somewhat monogamous. Males and females pair up and they cooperate in raising offspring, but somewhat solitary because they also take off and forage on their own.
Interesting. And enlighten us on how that work is really, really done. How does a group of researchers that want to learn about corvid structures, how would they go about doing that?
I mean, in any animal society, regardless of what the social structure is, the first thing that you have to do is recognize the individuals and keep track of them over time. And that means that you've got to get the animals habituated. In other words, you've got to get them used to the idea that there's a human in close proximity watching them all the time. And this is often very difficult because the animals often don't tolerate you, and recognizing individuals, particularly if they form huge groups and look amazingly alike, takes a long period of time. And so in baboons, where the groups are 60 to 80 individuals, if we have a student come out and work with us, it usually takes them about 4 or 5 weeks to learn to recognize all the individuals. Once you get the individual recognition, you can't believe you ever didn't notice it. It just jumps right out at you. But that's the really important first step. And when you can recognize the individuals, the sort of scales fall from your eyes. All of a sudden, you begin to see patterns in the interactions and so on. And this is, getting back to the crows, this is why we, for a long time, really didn't understand that much about corvid society as it applies to crows and ravens, is because they were really hard to catch and
Right.
mark, and without that, you couldn't recognize the individuals over time.
Right. Makes a lot of sense. So what kind of factors are you thinking about in your head when we're thinking about the complexity of of a society of these animals, how these animals group together? What kind of factors are you thinking about specifically and related to the crows, and where are you initially thinking of placing it on our tiers of complexity?
Um, the first of all, you're sort of interested in the size of the groups. For example, if we talk about, I'm a little bit nervous talking about this tiers of complexity, because in many ways, every animal society is complex, each in its own unique way. But
Right.
sort of at the bottom, I've put solitary animals, and let's start off by maybe talking about them because
Right. Okay.
take, say, a rhinoceros in East Africa, if in the few that haven't been killed by poachers. Um, Males are wandering all by themselves. Females are wandering all by themselves. And so they're pretty much alone all the time until mating takes place and there's communication between the two because the female usually attracts the male. And they come together, they mate, and then they separate. And after that, you do see animals in groups of two because you see mothers and their offspring, but otherwise they're solitary. And that's
Interesting.
pretty simple. And that's why I put them sort of at the bottom of my tiers of complexity because the size of the group that they live in is generally one.
Makes sense. Explain maybe from an evolutionary lens, what's the environmental circumstances need to be for a solitary animal tribe to emerge? Why would an animal be better off by itself? Would a herd of rhinoceros or a bunch of rhinos together not do better in the African savanna or whatever environmental niche they're in? Why does something end up being a solitary animal? Do we know?
Well, one thing that happens when an animal joins a group is that you have competition,
Right.
competition for food, competition for mates. And if that competition is sufficiently strong, it behooves the animal to leave the group and forage on its own where it doesn't have competition. So the general view is that ecological pressures drive the inclination to be solitary as opposed to joining a group. Um, if you are going to join a group, the benefits of group life have got to exceed the benefits that you would experience being on your own. Otherwise, you'd leave. And the
Interesting.
ben-
Right.
and that's where the interesting complication gets because when we talk about the benefits of group life, the group ought to give you something that you wouldn't get if you were on your own. More efficient food finding, more efficient access to mates, other sorts of social relationships, and so on.
Well answered. So I guess a solitary animal has to be able to fend for itself. So it would always be fairly fearsome, right? What we have here is our rhinos, moose, tigers, and leopards. All animals, they can definitely fend for themselves. They can hunt. They can do everything. And that would also be a property of solitary animals, right? They can't. A defenseless solitary animal would never emerge.
Unless it's a solitary animal that's very cryptic and hard to find, because
Right.
then its adaptive strategy might be to be difficult to see, difficult to find, and so on. But
Right.
yes, by and large, they've got to be sort of um, immune from predation, and all of the animals that you mentioned are pretty much immune from predation.
Right. Would it be fair to assume that throughout evolutionary history, there might have been time periods where rhinos were pack animals and then they went to solitary and then they went back to pack, right? It's not that that was a stable strategy throughout all of history, right? It probably fluctuated in group size based on that exact evolutionary niche where they found themselves, etc. Would that be correct?
That would definitely be correct, and we could sort of make a generalization that as we've tried to pigeonhole these individuals, these species into particular groups according to their typical social organization, that social organization is flexible, as we'll see when we discuss some of the other species on the
Right.
list.
Very cool. Okay. Anything else that you'd like to mention about solitary animals, or we move on to the next on the list? What do you think?
Let's move on to the next level.
Great. So, do you want to do this from the bottom up? Then does that
I
suit
I
you?
I think that would be the best way to do it because it sort of introduces interesting levels of complexity.
Gotcha. Perfect. Okay, so you have the list in front of you, right? Where would you like to go to next?
Um, Next, let's go to monogamous animals and
Monogamous monogamous
monogamous
mammals?
animals meaning one male, one female that pair together and they stay together for a long period of time. And um, so right away, the group size is larger than solitary, but not particularly large. And it's interesting that all over the world, about 90% of all birds are monogamous.
Interesting.
Whereas the opposite is true for mammals. Only about 10% of mammals are monogamous. So, this is a big feature of animal societies that we really need to explain. Why are birds by and large monogamous, and why are mammals by and large not monogamous? They're what scientists call polygynous, you generally one male and multiple females. But
Yes.
birds are monogamous generally because one of the dominant hypotheses is that it takes two parents to raise the young. If you lay eggs, then the eggs are vulnerable to predation. If you have chicks that are hatched from the eggs and have to be fed, they're also vulnerable, and it often takes two parents to raise a chick successfully. So right away, monogamy is a dominant feature of bird society, and this is most songbirds and many other birds. And some birds, on the other hand, deviate from that, and that is where a female can benefit by being the second female of an already mated male.
Right.
So take red-winged blackbirds, a classic example. Males come up from the southern latitudes into the United States in roughly February, amazingly enough, and the males fight and set up territories. Some males great territories, other males get territories that aren't so good. Females show up a few weeks later, and females fly from one male territory to another, sort of checking out the resources. And what they seem to be checking out is safe nesting sites, safe from predation, and so on. But the male's territory quality differs widely from one male to the next. So every female wants to mate with a male, but for some females, it's better to mate with this to be the second female of an already mated male than it is to be the main female of a male that doesn't have a mate. And that is what Gordon Orion's a famous behavioral ecologist called the polygyny threshold. That and so at that point, the mating system shifts from being monogamous to being polygynous. And that's a very simplistic sort of explanation, but that gives you an idea of why you get this flexibility in mating systems.
Right. Very cool example. My girlfriend was not happy to hear that so few mammals are monogamous. She was like, "Those are the good guys. Those are the good ones. They stick with the wife. They raise the child." The So if we go to mammals, then why are they so highly polygamous? That stable structure of mom dad seems like it would be better at surviving than the statistics of 90% being polygamous would say.
Well, your girlfriend has hit on the crucial question. If mammals are generally not monogamous, why are we humans think of ourselves as monogamous species? Well, one thing that is different between mammals and birds is internal gestation and fertilization and gestation. Um, so when males and females mate, obviously in mammals, the female is fertilized and carries the offspring in utero at that time. And then when the offspring are born, the female has the ability, because of lactation, to feed the offspring on her own. So this creates a situation in which, if you imagine, you should, in a way, think of males and females as different species. Each one is trying to maximize their reproductive success over their entire lifetime. That is, natural selection is going to favor individuals who pass along their genes to the next generation. And from males' perspective, this often means that once he has fertilized a female, the offspring can be raised by the female alone
Right.
without his assets. without him doing anything else. At that point, selection is going to favor males who leave their current mate and go to find another mate because they can maximize their reproductive output. So the general view is that for male mammals, reproductive success depends on the number of females you can mate with, not necessarily your investment in your current offspring. For females, it's quite different because the female, um, she can raise the offspring on her own as long as she is in good nutritional condition.
Right.
So for females, the major determinant of reproductive success is her physical condition, food, defense against predators, and so on. So the males and females are, in some respects, playing according to different rules. For males, there's one set of rules, for females, the other, and often the situation occurs where the male can leave his current mate and mate with another male. Now, let me emphasize that there are lots of exceptions, but the exceptions help you understand these particular rules. For
Yes.
example, in African jackals, if you travel around the African safari and you see these monogamous jackals, males and females, they hunt together. When they hunt, they come back and they regurgitate food to the pups that have been stored in a den. And the males and females are really both needed to raise the offspring. And if one of the pair dies, killed by a lion or something like that, then the pups will almost certainly die. So in that particular species, a male cannot leave his male and go to find mate and go to find another mate, because
Yes.
if he does, his reproductive investment will be lost. So it is adaptive for males. That is to say, natural selection will favor those males who form a stable monogamous bond with their females. And so, and that's just one of the ways in which monogamy in mammals can arise.
Really well said. I love this. I love this so much. I'm such a nerd for all of the amazing examples in the animal kingdom of how animals organize themselves differently, which is why I was so excited to have this. Like, that really well explained and really cool, and a very interesting point on how we need to think about the male strategy and the female strategy very differently across the animal kingdom. I see that in monogamous mammals you have gibbons here, but there's no other monkeys or apes in this category. Do we know specifically why gibbons, as in the monkey family, it became monogamous, whereas others didn't?
So I'll be a pedant and remind you that gibbons are apes and not monkeys. And that is a really good question. Um, Gibbons are territorial, and the male and female together defend their territory. They defend it by fighting against intruders, but much more often they defend it by these elaborate vocal songs that they sing in the morning that announces their presence on their territory and really deters any invasion from outsiders. And it looks like gibbons really need to cooperate to defend a territory against other gibbons, and that there's nothing to be gained by a female joining a male and a male and a female in an already mated pair. She will try and go out and find another male herself. Now, offspring often help out in the defense of territories, and things get very complex. But by and large, I think that would be the explanation. I no doubt there are gibbon experts who are quailing at my sloppy explanation, but yeah, that's it.
Everyone in that listens to me are known to be experts in gibbons. I'm sure they're all going to be massively critical of that definition. No,
Massively, right?
I have to ask because I'm ignorant to this, and please point out any time that I am ignorant, which is no doubt going to be a lot of times throughout this particular type of episode. What is the difference between a monkey and an ape?
So, monkeys, by and large, if you imagine a large evolutionary tree of shared ancestry, the monkeys diverged from the common ancestor of monkeys, apes, and humans
Right.
roughly 25 to 30 million years ago. Then you go along and you have a long common ancestry of the great apes and humans as well. The great apes, really including humans. And the great apes begin to diverge from that common ancestry about, say, 5 or 6 million years ago.
Right.
Orangutans maybe a little bit earlier than that. So the great apes, meaning chimpanzees, bonobos, gorillas, and orangutans. And gibbons are sort of lesser apes, so they're a little bit different. But those four, they share many more anatomical features with humans than other species do, many more than monkeys do. Their brain sizes are larger. And as we'll see, by some measures, their social organizations are more complex.
Right. So absolutely not a pedantic point there. That's 25 million years of evolution is definitely a point worth stating, because I think a lot of people use those terms synonymously and don't
Yes.
and don't
Right.
know the difference. But that's a very good one to draw. Where are we thinking next? We've done monogamous mammals. What are you thinking next?
So I've been trying to drink less alcohol. And honestly, it's had a pretty big impact on my health. I'm sleeping better, I'm exercising more, and my business is growing. The data suggests that people are drinking less alcohol than ever, which overall I think is great, but I'm still looking for a little treat at the end of the workday or a hard workout. And that's where Sentia comes in. Sentia is a 0% alcohol drink that feels like you're drinking something special without any of the downsides. It's created by neuroscientists and it's designed to give you that relaxing buzz, the same kind of feeling you get from alcohol, but without the hangover, brain fog, or impact on sleep quality. And it tastes absolutely delicious. They already have a GABA red berry, which is perfect to mix with a tonic or orange, or GABA black, which is awesome with Coke. Personally, I've been really enjoying the GABA gold with Fanta lemon on ice.
That's actually genuinely delicious. Like, I'm not even play acting there. It's actually just really, really good.
So you might be wondering, how does a drink with 0% alcohol give you that buzz? It almost sounds too good to be true. Well, this is the really cool neuroscience part. The secret is GABA, the brain's natural calming agent. And the different GABA flavors have different cognitive effects. Sentia's founder, Dr. David Nutt, has published over 500 independent research papers and written 34 books on neuropharmacology. What Dr. Nutt realized was that we can harness the same calming, relaxing effects from alcohol without any of the side effects. I genuinely think this could be the future of drinking. And they're also just releasing their first beer and stout, which as an Irishman I am dying to compare to Guinness. Sentia are offering my viewers 10% off their first purchase, and I genuinely could not recommend it more. I think even if you're looking to just substitute your one gin and tonic on a Tuesday with Sentia, the cumulative health benefits over time will actually be very noticeable. So check out Sentia, again, 10% off at checkout.
Okay, so in a lot of mammals, there are what are called one male groups, where there is one male and multiple females, and that grouping is stable over long periods of time. And those are species in which you've got females join with a male and other females, and there are two benefits that they gain from that sort of make them distinguishable from monogamous groups. First of all, the females gain benefits from being with other females. In some species, for example, there's cooperative rearing of offspring. Lions are a classic example. Female lions form these prides. They hunt together. They suckle each other's offspring. It's really beneficial for a female to be with other females. And often those other females are her kin. And males come in and they take over a female pride and mate exclusively with those females in that pride, and there's males are sort of coming and going trying to oust each other. from the control of a particular pride. And this pattern of either one male groups or multi-male groups around a set of females is a very common pattern in mammals.
Yeah, really interesting. How should we think about the type of environmental niches that are optimized for monogamy versus these one male groups? You brought up examples where females benefit from having other females
Yeah.
that are able to suckle their young, but would that not almost always be the case where females would benefit from having other females sort of interchangeably, but then they have less attention of the male because the male is distributed over however many females are in the harem? But talk about like what sort of scenarios cause those different structures to emerge? What do we know about it?
Um, is a complex group of both ecological and social factors that affect females. So I said a little while ago that the major determinant of reproductive success for males is the number of females you gain access to. And the main determinant for females is your nutritional condition.
Yes.
So if females are driven by food and males are driven by females, then the females driven by food will organize themselves according to the optimal intake of highly nutritious food. And that may mean for a female foraging on her own, at which point the males um, can uh, can pair up with a female, and then they will be monogamous. But it may also benefit females to tolerate other females because that helps them defend an area, that helps them find food, that helps them detect predators, at which point a male has the opportunity to control multiple females. And it's in the benefit of the females to join with other females and forage together like that. So
Right.
that it's a complex set of ecological factors that, from the female's perspective, are based on protection against predation and finding food and being in healthy, good condition. From the male's perspective, it's how the females are dispersed. So this leads to one of the sort of basic dogmas of bird and mammal mating systems. Female behavior is dependent on food and nutrition. Male behavior is dependent on females. And so it's the females that sort of set the stage and create the potential for males to be polygynous, or the fact that they can really only be monogamous. And there's a beautiful set of experiments by a guy called Nick Davies at Cambridge University, and he studied this sparrow called a dunnock that lives in the Fellows Garden of Oxford and Cambridge. And in those cases, the food is really rich in some areas of the garden and not so rich in others. And in the poor areas, the females are driven by the need to get food, and they space themselves out widely. One female here, one female over there, one female over there. At that point, the male really can only be monogamous because
Mm.
he can't control an area that contains multiple females. Move to a richer area of the garden, and the females tolerate each other because there's so much food, it's okay. Well, at this point, the male has the potential to be polygynous, to have multiple female mates. So males compete with each other for territories that include multiple females. So it's the food that's driving the females and the females that are driving the males.
Right. And will does this mean that or males, I should say, males will always tend towards polygamy if they're permitted, if they're allowed, if the ecological niche permits it?
That's a really interesting question. And a lot of it, and there's a lot of cultural baggage to that. I mean,
Right.
it's certainly there some some good friends of mine who were actually studying lions, I believe, at the time in Tanzania, and they got married there, and they were filling out a wedding certificate. And for males, you could check various boxes. Are you monogamous? Are you polygynous? Are you potentially polygynous? And of course, the males and his buddies all said, well, at least check potentially polygynous.
Potentially.
But of course, his fiancee wanted him to check monogamous anyway.
Yes.
Uh, and culture has a lot to do with it. The typical, and then of course there's the problem of what are the cultural norms and what are the actual behavioral practices, and that gets also into a complex sort of picture.
Right. Because obviously there are, if we do talk about humans, there obviously are human cultures that are a lot more polygamous. Some are a lot more monogamous. You know, it's much more common in Islamic traditions for men to have multiple wives. Not common in the West, but you know, you might get a lot of cheating and promiscuity. And it's just, do we know, or do evolutionary biologists or anthropologists or whoever would classify this? Like, are humans classified as more monogamous or more polygamous?
Gosh, one of the great beauties of my scientific research is always focused on animals and not humans. And I can tell you some excellent people that you should interview on your show, and they will answer exactly those questions because they will
Yes.
know all the behavioral background. But so can I pass on that?
You're gonna plead the fifth. You get
Yes.
one plead the fifth per episode.
Yeah.
Awesome. Okay, no, really well explained. I think it's a super interesting conversation, and we can really see how complex the factors are that will drive a particular societal structure over time. It's a lot of factors. Where are we going to next? And would you place, do you think, knowing that list, are we going to put the one male group in C, but ahead of monogamous animals, or in B? We can leave it in B for now, and you're always willing to change it later.
Um, as
Like, is it
long as we're
sufficiently more
not talking
complex
about,
than monogamous mammals, so
yeah.
we want a different tier?
You see, the one thing that makes me nervous about this is the greater degree of complexity because um, each species, I mean, so monogamous, you might say, well, really, that's a simple group in which male and female interact with each other. But consider the exquisite timing as a male and female bird raise their offspring. If you watch the birds in the springtime, they're flying back and forth and the timing is perfect. They're not overlapping with each other. They both have to be feeding all the time. And the ditto for the protection of the nest and the detection of predators. So it's a really complex society, and don't be fooled by the fact that it's simply monogamous.
Yes.
You could say to one of your human friends, you guys have been married for 35 years. It must be pretty simple relationship. And they would say, absolutely not.
You duck as
So,
they throw their shoes at you.
yes, exactly. But uh, so let's move. So we've got the idea that there are often one male groups, and that
Yes.
happens because um, um, males compete for the access to females that are clustered in a group. It's beneficial for the females to be in that group, so it's a great deal for the males if they can control that group. And males compete for access to that. And
Yes.
often what happens is that there's one male in the group at a time, and and he's in that group until he is ousted by
Yes.
another male in particular. And the classic example of the conflict between male reproductive strategies and female reproductive strategies is infanticide. And this was originally discovered by my colleague and friend Sarah Hurdy in langurs in India, which were one male groups, and the male would control access to the females in that group. other male, so where the excess male? Well, they're cruising around in all male groups, and they're shadowing these one male groups, looking for an opportunity to oust the resident male and take it over. And sometimes they do. So a new male comes in, ousts the resident male, and what does he try to do? He tries to kill the infants of the females in that group at the time, particularly the small infants. Why does he do this? It was originally thought to be some sort of pathology having to do with crowding, but in fact, there is an evolutionary explanation for that. It turns out that the tenure length of the male in one of these groups is 7 or 8 months. So think of a male as having two strategies. One is he can oust the resident male, and he's going to be there for about 7 months. And whichever female becomes sexually receptive at the time, he can mate with and produce his offspring. That's one strategy. Another strategy is to accelerate the process, that instead of just waiting for females to become sexually receptive, he goes around and he kills the infants of females who are lactating at the time, raising
Right.
their infants. The females fight like crazy to prevent him from doing that, but he's bigger and he kills the infant. At which point, within a week or so, the female resumes sexual cycling and the male mates with that female, and he has effectively replaced one male's offspring with his own offspring.
Right.
And that's that happens in lions, where groups of males take over a pride of females and try and kill the cubs, and the females try and fight them, but are often not successful. It happens in langurs. It happens in a number of species. And it really encapsulates the fact that the males and females' reproductive interests are not completely aligned.
Right. It's a brutal, brutal example. What do you think that tells us about the females and how they grieve and like emotions over time? Because, obviously, if we're anthropomorphizing there, this never
Mm.
happens in humans because the woman is like, what the hell? Well, they're probably grieving for a few years and then looking for a different mate. But there's no universe in which that woman would go back to that man. So, like, what do you think it says about that female that after that, and they maybe grieve for a week or 2 weeks or feel bad or negative in some way? And I know that I'm anthropomorphizing in my language here, but you
Mm.
have to imagine that these organisms, they feel emotion, they can feel sadness. You would almost certainly imagine. Why do you think it goes back to that male then that they just watched kill their baby? I'm assuming they have memories that are 2 weeks old. It's not like it's a fresh slate. Like, what do you think that teaches us?
Um, well, it it's it's hard to say. I
Yeah.
must say that from if I speak of my own personal experience, I mean, I have watched baboons and vervet monkeys for many, many years, and you become attached to your subject. You become emotionally involved. You really sort of, you empathize with them. And and yet, when a baboon female has had her infant killed, and within a week or so she is mating with the male that killed the infant, that makes you think, it
It's a
made
bit
me
puzzling.
think, these are really different. This is a, and this puts a check on your anthropomorphization.
Right. Really
And
does.
yet, at the same time, if a female is carrying an infant that when the male tries to kill the infant in baboons or langurs or whatever, the females fight like crazy to prevent the male from doing that. So you can feel great empathy with that. If a female's infant dies and she carries around the dead baby, for a long period of time, if the baby dies of, say, disease or being killed, for example, that really tugs at your heartstrings.
Right.
And when for infant primates, if they're very, very young, the first couple of months, if the mother uh, dies, then the infant will die. If the infant is, say, 11 or 12 months old, if the mother dies at that point, the infant will probably make it and will be carried by mothers, sisters, and others. It has a good chance. But in between, if the mother dies and the infant is 6 or 7 months, the infant struggles and struggles, but is not going to make it. In all these cases, you feel incredible empathy for what's going on with your subjects. You mean you're still a scientist, you're taking data, it happens, but you feel less empathy when the female mates with the male who killed her infant.
What would that? Have you? You've spent many decades in the jungles studying these animals. Have you witnessed that with your own eyes? And I would just burst out crying. I'd be like, this is way too hard. If I had to witness that happening right in front of me and just take notes in my notepad, like I'd just burst out crying. I wouldn't be able to do that. I don't think, even though it's important and you can't interrupt. I understand that, but like, God, that's hard.
It's hard. And seeing an infant die as it struggles and struggles day after day, that's painful. That's hard.
What is your responsibility in that moment? Would you can't throw off the ecosystem balance if it is a struggling infant, you're not able to rescue that ever? Or like what are the actual circumstances there? I'm really curious in how this works.
Well, so here's an example with baboons, not an endangered species, and the females will have multiple offspring during their lifetime. We have watched baboons, infants struggle and die, and we didn't put out food or anything like that because our objective is to get an understanding of baboon society and the factors that determine who survives and who doesn't. And
Right.
our scientific objectives are important. It's not an endangered species. Contrast that with my good friends Kelly Stewart and Sandy Harcourt, who studied gorillas, highly endangered mountain gorillas. There just weren't very many of them at the time. An infant gorilla gets caught in a snare that was put out originally by poachers to try and catch duiker, a small antelope that they want for food, or else they want to catch a gorilla for sale to a zoo. That was, it's been really a terrible thing. Well, at that point, you're dealing with an infant that is one of the few infant mountain gorillas in the world.
Right.
And you've got to intervene, do what you can. And that's why there is an organization called Gorilla Doctors that provides veterinary care and advice for people doing research on gorillas. And that sort of intervention is entirely appropriate given the fact that the species is endangered. And Sandy Harcourt, in fact, risked a lot by going up to these gorillas and removing the snare from this infant. And with male silverback gorillas screaming at him while he was doing that. But the infant got out of the snare. And that was a sort of intervention that I wouldn't have done with baboons, but it was really appropriate with gorillas.
Right. So you have to kind of make a judgment call. That's so brutal. It's so tough because you need, and you also don't know if humans start intervening in that case, how you could be throwing off the ecosystem or disrupting the balance, and then your data could be useless because you're not studying the ecosystem as it is. You are having some intervention, and it could be having some effects that you don't even realize.
And you have to make a decision, because if you're studying a species that is like baboons, that is not at all endangered, then
Yeah.
all of a sudden the science takes precedence. But if you're studying a species like gorillas, where there are only a few left in the world, then the conservation initiatives, they certainly take precedence, at least
Right.
in my view. Yeah.
Yeah, for sure. It's so tragic that gorillas are nearly extinct. Is that getting better or is that getting worse?
Oh, it's definitely getting better. And
Okay.
and in the case of mountain gorillas, it's getting better because of the enormous success of gorilla tourism in Uganda and Rwanda.
Okay.
And but and now money from tourists going to see the gorillas is making a huge economic impact on the local countries and created an enormous incentive for people to preserve the gorillas and their habitat. So
Right.
that's a conservation success story.
Great. Great. Okay. Very well said. Lots of really interesting things there. Let's move down the list. What are your thoughts?
Okay, so you've got a case in which females are gathered together because it's beneficial for them to do so. And what are the males going to do? And as in the case of the langurs, males come and go and they get ousted from, but sometimes the males hang around and they stay there for a while, either because they want to have sort of a sustained mating opportunities with females, or because it's beneficial in other ways. Elephants are a good example. Um, Females form these herds, and the females stay together, and you have a mother and her offspring who've grown up to be adults. So you've got a matrilineal herd of elephants, and males come in and they compete for the opportunity to mate with females, and sometimes multiple males stay, sometimes only one male is there. But in baboons, you get a group in which there are multiple males present in the group at the time, and they may stay there for many years. And at that point, the males form a linear hierarchy, and the males are competing for the opportunity to mate with females as the females become available for mating. So here you moved to a situation where you either have one male and multiple females, or you have multiple males and multiple females. And a lot of it depends on the reproductive opportunities that the males have in that particular case.
Right. Very interesting. And is there any other examples? I was surprised in these animal groups that elephants were the only example we gave for that. Is there other examples of what about stuff like whales and dolphins? Are those similar to this structure, these matriarchal pods?
Um, they're, they are Certainly, females hang out in dolphins together, but the males often form these coalitions with each other and try to take over access to females. And there, the social organization is really complex. And we know a lot about this from work on the west coast of Australia and also from Sarasota Bay in Florida, where the males form these bonds and try to oust other males from access to females. And how long the male female association stays depends on sort of a variety of local factors. But there's all sorts of strategies going on. And this is where you get into really interesting cognitive operations, because it looks like males have alliances. Male dolphins have alliances with some males, and then they have higher order alliances where there are alliances between alliances. And it gets really complex and sort of political almost.
Right.
And a lot of it has to do with the different strategies that males have for maintaining relations with females.
Fascinating. So interesting. You've spent a lot of time studying, I believe, bonobos and chimpanzees.
No, I haven't. I'm a sideline voyeur for bonobos and chimpanzees, but there's all sorts of interesting things going on there. And I should say that now that we're moving up into levels of complexity, um, so we've reached the point at which there are multiple males and multiple females in a group at the same time. Or another variation on that is in gelatos, this kind of baboon that lives in the highlands of Ethiopia, where you have a number of one male groups, but the one male groups, each containing one male and multiple females, they come together in groups, and one male group might ally with another one male group and forage together, beside each other, but it's still one male and multiple females. And then many one male groups may come together in forming these enormous herds of 1,000 individuals.
Wow.
And at that point, you don't really know all the animals in the particular group. So the core is still this one male unit, but the one male units coordinate with each other, and it gets really interestingly complex. And this is another example of how each society can't be judged simply by the number of males and the number of females. It's the nature of the social relationships that they form within those.
Right. Right. Talk a little bit about that more then. What kind of relationships emerge when you get into those bigger group sizes? You have more, rungs in the hierarchy, I presume. How does that sort of flesh out when you get these larger and larger groups?
Well, let's take elephants and baboons, for example. So it's an interesting convergence, is that in baboons, if you came out with me and walked among a bunch of baboons and you had learned to recognize the individuals, that would have taken you multiple weeks, but you learned, then you'd notice that there's one female who, when she walks through the group, the others kind of step aside. She's not aggressive. They're not horribly submissive. They just sort of give way to her. And that is the alpha female in the group. And if you stayed and you continued watching for a year or so, you'd notice that this ranking directly below the alpha female is her daughter and her other daughters
Right.
and her sons when they're young. So all of a sudden you would realize that this is a highly structured group. It's not just a bunch of females. It's a series of female matrilines where at the top you have the highest ranking female and then her daughters, and then the next ranking female and her daughters, down to the lowest ranking female in the lowest ranking family. And the intricate alliances that happen within families and between families are what makes baboon society, and again this is the same with elephants, it makes it so interesting. And we always said that the interactions among females in a baboon society are very much like the interactions among females in a Jane Austen novel. There are two fundamental principles. One is get in with the high ranking families if you possibly can. And the second,
Right.
stick with your relatives unless your relatives are an encumbrance to you. So that a lot of what goes on is females trying to establish relationships with higher ranking individuals so they can form alliances so their family can do as well. And what's been interesting, again, that adds another layer of complexity, there are two long-term studies of baboons, one run by my colleagues at Duke and Princeton, and on baboons in Amboseli in Kenya, that's still going on, and the one that Dorothy Cheney and I ran for a long time in Botswana, along with Joan Silk. And we kept waiting for years and years and years, collecting data to see which females would be most reproductively successful. And we sort of thought it would always be the highest ranking females, but it wasn't. And fortunately for both of us, we both got the same alternative answer. The females who did best were the females who had the strongest social bonds with other females,
Right.
often with their kin. So social relationships, it wasn't that rank was unimportant for things like longevity and reproduction. It was important, but slightly more important, but measurably more important, were the strength of these social bonds with other females. And this was interesting because we began to discover it just about the time that sociologists in the United States were showing that the best predictor of longevity in American females is how tight your social network is. And
Right.
now we hear this all the time. It's more important than smoking, drinking, and risky behavior is maintain your social friendships because that helps keep you alive.
Yes.
And the idea was always in humans, well, this is because of our high pressured, tense lifestyle that we have. But in fact, the same principle holds with baboons, which means if you take a society that is much simpler than ours, I mean, remember that with baboons, there are no tools, no language, um, very little of what you would call culture. And yet, what's important are social relationships. So
Yes.
that's one way of saying, here's a layer of complexity that it probably is going on a lot in monogamous species, in species where there's only one male, in species where there's multiple males, and it's sort of complexity on a different axis from group size that is now becoming important.
Right. Has there been good studies showing relationships between group size and, serum cortisol levels? Because I would assume that that's part of that longevity equation is just the bigger the social group, the lower cortisol you have in your body, which of course has lots of deleterious effects over time. Is that part of the equation?
And there certainly is interest in taking those physiological measurements and measure stress, but it's not group size. You emphasize group size, and what I would like to steer you away from is it's not the size of the group, it's the nature of the social relationships that you have in
Right.
the group. For example, in baboons, where you've got these structured matrilineal families, what really distinguishes individuals who seem to be successful is not how many social relationships they have, but the few really good, strong social relationships they've got. Um,
Amazing.
so group size was originally thought to be a major determinant, but now it's much more subtle than that. It's the nature of the social relationships that you have within the group, which uh, but on the other hand, to follow up on one comment that you made, what is it about a close social relationship that makes it translate into longevity, better infant survival? Well, we don't really know. Is it and when you think about it anthropomorphically, if I'm living in a society, what is it that's good about having a really close friend? Well, I would say right away, no matter what happens, that friend's got my back.
Yeah.
Well, maybe that's true for baboons. Maybe baboons go through life, and if they've got a few really tight social friends, that that is going to be advantageous to them. It's going to make them relax, lower glucocorticoids, less stress, more relaxed dealing with infants. Maybe that's it. Um, we don't really know just yet, um,
Yes.
but but we're trying to work it out.
It's really interesting because I remember reading human data a while ago that said the same, that it's not so much about the quantity of your social relationships, but about your perception of those social relationships, how strong you perceive them to be on your own subjective level. Do you think that the fact that there seems to be similar data in these monkeys and great apes, that does is that some evidence for like higher order perception of social relationships, and like that there is some sort of higher order cognition going on there, that it's not just purely the quantity, that there does seem to be a perceptual layer or some subjectivity on the side of the monkey slash ape on like how strong those relationships are? Does that make sense? Do you think that that's
That does make perfect sense, and it's actually one of the things that is actively people are actively involved in research on, because with this social complexity goes the pressure, think of it, evolutionary pressure, to be more perceptive about the nature of social relationships. So we now know that, for example, baboons not only have close social relationships with some, but not others, but they recognize the social relationships that exist among others. So if you've got a baboon sitting there, a bunch of baboons sitting around together, and if they're females and you play from a concealed loudspeaker in an experiment the distress cry of one of their offspring, the female sitting there will look at the mother as if they know that voice goes with that offspring goes with that mother. What are you going to do about it? And there's lots of evidence that animals' perception of other animals' social relationships affects how they go about their daily lives, which is another way of saying that the greater you get social complexity in these relationships, the more you have natural selection favoring those individuals who are unusually perceptive in recognizing the social relations of others,
Right.
which is a very interesting sort of take on what it is that's important about human cognition.
Right. So cool. Amazing. Really well explained. I love this. You have an encyclopedic knowledge of the animal kingdom. Which is just amazing and fun to be able to pick at. Maybe time to I have here multi-male fusion and fission societies. Do you want to explain what that means? And if that
Yes,
would you put that as more or less complex than multi-male primate groups?
more.
More, okay.
Yeah. I mean, at the moment, my no doubt I will be criticized by people, but at the moment, this is really interestingly complex, and it raises a whole lot of questions about this. So chimpanzees, so we've been talking about animals that in their species typical social group, they move as a group. So if you come out and watch baboons, or we go out and watch elephants with Cynthia Moss in her long-term study, she'll say, oh, well, that's the Q family. And they're always together and they always forage together. And with baboons, if we go out to watch a particular troop, the group is always together. They may be spread out, but they move as a unit. With chimpanzees, if you imagine that there is a group of chimpanzees that live in a particular area and they always are found in that area, but within that area, the individuals move in sort of idiosyncratic ways, and they're definitely not always together. They
Okay.
may be foraging as individuals. They may be foraging with a couple of other individuals. They may come and go. And that's why it's called a fission-fusion society. And that's characteristics of chimpanzees and bonobos, and also, interestingly, of spider monkeys in South America. But the chimps and bonobos are really interesting. This is why the fission-fusion society is sort of challenging to study, is that, first of all, your group mates aren't always there. Sometimes you're on your own, sometimes you're with them, sometimes they aren't. What this means is that as a chimp moves through the forest, it can acquire knowledge about predators, about food, that it has and other animals don't have. And so then if it joins together with other group, has the opportunity to share knowledge that it has or not share knowledge that it has. It also has to consider the possibility that other animals have knowledge that it doesn't have. And so this is a complex level of cognition, and this gets right into one of the hot topics in primate cognition, which is called theory of mind. And
Yes.
um, shall I just explain that
Please
briefly?
do, yes.
Okay, so if you have a 3-year-old child, and this is a classic experiment done by two English psychologists. So you're sitting there with a 3-year-old child and you're looking at a stage where there are puppets. And here's a puppet called Maxie. And Maxie has a piece of candy. And she wants to eat that piece of candy, but she has to go to the bathroom. So she doesn't want anybody to take the candy. So she hides it underneath the blue sofa that's on the stage. Maxie then leaves. And then you say to the 3-year-old child you're with, we're going to fool Maxie. And we take the candy from underneath the blue sofa and put it in the red cupboard. And then you say to the child, When Maxie comes back, where is she going to look for the candy? And a 3-year-old child will generally say, in the red cupboard, because that's where it is, because that's where the 3-year-old knows where it is. But she doesn't know that Maxie doesn't know.
Right.
And so Maxie comes in. Now, there's nothing in Maxie's behavior that is a tip-off that tells you that Maxie doesn't know. It's just that the 3-year-old can't imagine what Maxie does and does not know, how it might be different from what she knows. As the child gets older, 4 or 5 or so, they'll give some intermediate answers like, well, Maxie won't know where to look. Or Maxie will say, she will look under the sofa and she will be wrong. And at that point, you get to this point, a child passes the false belief task. She knows that another individual's belief is false. The big question in a lot of work on primate cognition is, do animals have a theory of mind? Do they recognize what another individual doesn't know? And
Yes.
the answer is, we're working on it. And the way to describe the complex thing has to do with fission-fusion society. And this traces back to experiments that have been done by several primatologists, but I'll describe 2 experiments that were done by Kathy Crockford at the CNRS in Lyon. And so a chimp is foraging through the forest, and it encounters a model of a snake, a very poisonous gaboon viper. It usually gives an alarm call at that point. So it's seen that. So in this particular experiment, the observers, that happened. The chimp saw the snake, gave a quiet alarm call, and then they waited. And they waited for several minutes before another chimp comes along. Now, remember, this is a fission-fusion society. So the question is, does the first chimp know that the second chimp doesn't know that there's a snake there?
Right.
And so, and if that's the case, does it give an alarm call to warn the second chimp? Or does it make a judgment about the second chimp's intelligence, judging from how the second chimp behaves? And there was evidence in this first experiment that Kathy and others did that that a chimp was sensitive to whether the other chimp appeared to know that the snake was there, and it gave an alarm call if a second chimp seemed not to know it. And everyone said, well, yeah, but you could just look at the second chimp and see whether or not it doesn't know it. So Kathy Crockford did another experiment in which the first chimp sees the snake, and then it hears from a concealed loudspeaker a vocalization that is either a vocalization given as an alarm call or another different vocalization that is just given as a contact call, between individuals. If the playback experiment gave just the contact call, indicating that the chimp had not seen the snake, then the first chimp gave the alarm call.
Right.
So that's a sort of clever set of experiments that, of course, people are discussing the details of the experiment and whether it really proves it. But fission-fusion society places unusual demands and opportunities on individuals that you tend not to get in a society of baboons or elephants, where if somebody discovers something, everybody automatically knows about it. And so
Right.
that's why and fission-fusion society also means, think if you've got allies, and you really count on these allies. And we know that male chimps have close relationships with particular other males with whom they hunt together and share meat together and patrol the border together. But sometimes your buddy is not going to be there. So what are you going to do? And are you going to take steps to recruit your buddy? Well, the buddy could be, hundreds of meters away. and out of sight. So the fission-fusion society is a really complex and interesting society. And at the moment, I would say it's kind of different from the other societies we've talked about.
Right. Really interesting and well explained. If they are, if the individual members of the fusion fission society are sort of independently nomadic and idiosyncratic, how do we even put it together into one society? Are there, how do we, I'm wondering when researchers are investigating a tribe, how do they place them together as one? Do they map their locations over a long period of time and see that they perform like large actions like attacking together, or like what is it that actually binds them together if they are so individual and nomadic and it's hard to track their movements over time? And do you know what I mean? How do they even
Yeah.
make
Yeah. I mean, the first step is that you go out and, I mean, if you really don't know anything about the chimps in the area, you have to habituate them, learn to recognize individuals, and then after a while, you start seeing new individuals, and you add these individuals. So I've seen all these individuals in this particular group over and over, and pretty soon you stop seeing any individuals you don't know. So
right,
right away, then you conclude that in this geographical area, there are always these particular individuals, and that can take a long time. But then once you've done that, then you start following their behavior. And one of the things that a primatologist or any animal behaviorist would do is would go out, pick an individual, follow it for half an hour or 2 hours or a day, for whatever length of time you want to sample their behavior, and then do that for another individual and another and another and another. And over time, you build up a library of who does what to whom when they're with whom. And
right,
in baboons, it's kind of easy because it's always in the same group. In chimps, it's more complicated because you have to say, well, who does what to whom when they are together, and how often are they together? And so John Matani, for example, one of the experts in chimp behavior, he followed male chimps in a particular community for many, many years. And he found out that males had, even though they weren't always with their preferred partner, they had individual in the group with whom, when they were together, they groomed a lot. They also shared food after a hunt. They went on hunts together. They patrolled the border together. Because what happens in these chimp communities is that it may be fission fusion in the inside, but the males often get together, and females too, and patrol the border against other males in other communities elsewhere. And so this is a highly charged situation because
yeah.
animals can be killed under these circumstances.
And
So,
don't chimpanzee societies also go to like civil war sometimes? Don't they war in each other? Something happens and then they choose sides and then they'll start warring with each other. Does that happen?
well, I mean, John Matani has been involved in this one, perhaps the largest community of chimps at Ngogo in Uganda, and he has paired together with a couple of filmmakers to make two good films. One is called The Rise of the Warrior Apes. You can see it on YouTube. And the other is Chimp Empire, which is a little bit better. And the Chimp Empire describes the fact that this huge chimpanzee community separated into two and engaged in battles with each other. And the question is, were the separations along kinship lines and so on and so forth? So at that point, he had to say, well, how am I going to figure out who's in which community? Is
Right.
this north, south? And you just have to go out and watch and take detailed data on who's on which side. And eventually it all becomes kind of clear.
It's funny to me how manual a lot of this processing is. For in my head, I'm thinking, okay, there's definitely like cameras at every angle, and then all of the video footage goes into like a computer vision algorithm that assigns each one with how much time they spend with different, and then you get all these like really structured relationships between all the chimps. But it's mostly just following one of them for 30 minutes and seeing who he hangs out with. It's
And doing that over and over
over
and
and over
over again.
again.
And, so this brings us to, how important it is to have these long-term studies of known individuals. And there's been a lot of talk recently about how AI is going to revolutionize animal communication and cognition because we're going to be able to talk to the animals. And that you can just sort of, AI is going to take over the work of what we do. But when you think about it, this is what we know now. When one baboon approaches another baboon and the approaching animal gives a grunt, how the other animal responds depends crucially on, are they kin? Are they not kin? Did they interact yesterday? Did they interact with each other's kin
Right.
yesterday? What's the long history of this group? And of course, this is particularly true with chimpanzees. These animals live together in the same group and interact over and over and over with the same individuals, and their history is as important as the vocalization itself. So you got to know the history.
Yes. So context is highly important. I'm curious on that though, as someone who's studied animal communication a lot. Is it going to be possible in the future that our dog barks and then we can understand vaguely what it means and it translates, and there's some way of verifying that that's actually correct and not just a hallucination by the AI? Like, do you think is this science fiction, or is this like a thing that we could actually eventually work towards?
You can learn a lot by just good old fashioned ethology without the AI, although the AI can help on certain things. If you take recordings of your dog's bark and then you pose the question, does this dog give acoustically different barks in different social contexts? Does it bark differently, for example, when it wants to go for a walk than when it wants food? How to tell the difference between the different barks? That's where AI is awesome. They're really
Yes.
good. But you record 60 barks given before taking a walk and 60 barks given when hungry and see if they're different. But on the other hand, that's one tight little relationship between you and your dog. If you want to talk about the relationship among 60 or 70 baboons, you can't just make the recording and then draw the conclusion. A lot depends on the history of the animal and what's going on. I said at one point in interview, saying that you can go out and say what a baboon's grunt means to another baboon without knowing anything about the animals is like opening Pride and Prejudice to page 171. And Mr. Darcy says to Elizabeth, yes, and explain what he means by that without knowing anything else about what's passed beforehand.
Right.
Um, you
Right.
got to know the context.
A good example. Makes sense. But does that mean that in theory you could accompany the grunt with a video, and the AI model could learn from the video itself and the sound, and that is that context, and maybe you even give it all the context of those particular ape interactions in the past. In theory, there's information there to be deciphered that we might be able to understand, and it could help us really understand truly how complex these societies are. Do you think that's coming in the next 5 years, say?
Well, no doubt the vocal recognition software is there already. The face recognition software is there. And so, yes, and the answer to those questions is definitely yes. Um, how are you going to input the historical data? Well, the historical data has got to be gathered by a human, but you can certainly set it up, and you can take your Excel worksheet and put all that data in, and then you can start to make sense out of it. So there's absolutely no reason why the ability to automatize a lot of this data isn't going to be extremely helpful. But you've
Yeah.
got to know what kind of data you need. And a lot of that comes from watching the animals. And the other thing is that a lot of this emerges from observations and experiments that people have made when they've spent a lot of time in the field with the animals under natural conditions. And often this is very boring. I mean, often the animals don't do terribly much, but that's when you get your ideas.
Right.
So it would be I guess my aversion to the automation is that if I think of, some of the times where I've really learned something about the animals, it's during these hour-long follows where not much is happening, but you're watching and you're thinking.
Right. Makes sense. But it's so you're enthusiastic, but there's a lot more figuring out to do, and it's nowhere near as simple as people might think that we're going to be communicating with these animals just directly, and it's going to be seamless, and it's going to uncover a whole lot. Way more complex than that. Very contextually dependent. Um,
I mean,
and
when you think about it, though, is the interesting question, what is a baboon communicating when it interacts with me? Or is the interesting question, what is a baboon communicating when it interacts with other baboons?
for
Because if
sure,
you're interested in the evolution of language or the evolution of communicative complexity, what natural selection has worked on is the behavior of animals under natural conditions interacting with each other. So that's where the gold is. The rest is kind of artificial, and uh, it might be interesting if you've got a pet or something, but
yeah, I
to
think
me,
people
it's
want to
much
talk to
less
their
interesting.
dogs. I
Yeah,
think people really want to just talk to their dogs. I think I've seen that a lot.
and more power to them.
Yeah, who can blame them? Come on,
Yeah,
who?
exactly.
I am okay. Amazing. Again, so much interesting stuff there. Interestingly enough, we still have birds and corvids unranked yet. Are you going to place them higher in complexity than the primates? Because that will shatter my mind and reshift a lot of things I would have thought. Where are we thinking of placing birds and corvids?
I mean, think about some of the recent work that's come out on tool making and tool use in corvids. I mean, they're incredibly imaginative about the ability to bend tools in order to allow them to gain access to food. And this is now I will resurrect again my anxiety about this hierarchy of lists because every species has something to offer that is intriguingly complex. I mean,
Yes.
when you think about it, Arctic terns, a bird with a tiny brain, navigates every year from the Antarctic to the Arctic and back and does so flawlessly. Is it particularly intelligent among birds? I don't think so, but it really is good at that particular task. And
Yes.
corvids are amazingly good at tool making. And that's not to say that their social organization is necessarily more complex than that of any other bird. So this is a slippery topic, and trying to make a hierarchy is probably a bad move.
I promise you're not going to have to defend your PhD thesis here. There isn't going to be five examiners grilling you on every single one. And I understand there's many examples. It doesn't necessarily fit into the easiest tier list, but it's an accessible format for people to kind of see them roughly compared. So, we'll add the disclaimer that there's error bars here, and there's some things with an asterisk, and actually animals are more complicated. But if you had to place these, are you happy with where the primates are? Where
Yeah,
the
I think that um, the corvids are easily as complex as any of the primates in their social
Wow,
organization, and birds as well. And I I do think that the fission-fusion societies are. I mean, we're only beginning to learn about the complexities there, and I think they pose some really interesting problems. Um,
fascinating. I was not expecting that. And do we have good ideas on theory of mind in birds? Birds and corvids? Is there good evidence that they have second order theory of mind?
no,
No.
um, and now I could be. No doubt, there will be colleagues who would say, "But what about this?" And I could be wrong, but the whole theory of mind question is open at the moment, and I think there's increasingly intriguing evidence that uh, chimps and bonobos um, may have more of a theory of mind. And also, I've created a sort of dichotomy: either you've got it or you don't. But there are a lot of complex wrinkles at
Yes.
when this happens, and for example, there are lots of examples in lots of mammals of subordinate males looking furtively over their shoulder and then sneaking a copulation with a female that ordinarily they would not have access to. What is the subordinate male thinking? Is he thinking the alpha male can't see me and so I can get away with this? Is he making a judgment about the relationship between seeing and knowing? There are some intriguing experiments that try and address this issue, but it's a complicated issue. Maybe the subordinate male has just realized that if the alpha male's head is turned, he can get away with the subordinate male can get away with a sneaky copulation. Maybe that's all he knows. Or
Yeah.
maybe he's thinking his head is turned, he can't see me, and if he can't see me, he can't, and you can imagine. And
Yeah.
so this is one of the challenges of doing this kind of research: is how do you define an experiment that captures all the complexity of natural social behavior, but allows you to choose between a hypothesis that yes, they can do it, or no, they can't.
Right. Yeah. I completely get it. And I think this positioning of corvids and birds versus the primates really does depend definitionally on how you say operationalize the complexity of the society, the social structure. Because I would have thought, if there's really good second order theory of mind evidence, which I think there is in great apes, that almost inherently puts it ahead because it's able to store more minds in its mind, basically. Like, I have this relationship with this, I have this relationship with this, and it's hierarchical, and that seems to me more richly complex than. Now, I'm no expert in corvids. I'm just kind of assuming that corvids can't do that, but that's going to be a controversial call if we leave the corvids as more complex than I think the primates.
And that gets into sort of fundamental discussions about how the brain works and what constitutes complex cognition. I mean, there's some very interesting arguments that say that um, it's not one specific ability that we should be looking at. It's the ability to combine memory and perception and deduction in it's overall general intelligence. And I mean, remember that chimps and bonobos have brains that are quite a bit larger than those of baboons. And what's that brain getting them? Well, certainly the chimps make tools. and baboons don't. But capuchin monkeys also make tools that are really very sophisticated, and their brains aren't particularly big. Um, so, trying to brain size is a complicated issue, and it's not going to solve the problem.
Yeah.
But on the other hand, there are some really interesting questions about how the brain works and how you deal with superior general intelligence as opposed to particular intelligence. And when you think about, I mean, there's one hypothesis that says, think about those Arctic terns. They are specialists in celestial navigation and other forms of navigation from pole to pole, but not much of anything else. Whereas other animals may be a little bit more generalizable. But this is a big debate that's going on at the moment.
Yes. Yes. Okay. See, you're happy to keep corvids ahead of the primates and
Yeah,
uh,
just leave.
have the absolute tyrannical revolution in the comment section on this.
I just uh, let's just realize that this is not a hierarchy. This is meant to be a characterization. And corvids are an interesting species because of the tools and because of their complex societies.
Okay. And birds. What do you where do birds go into this? How do normal corvids diverge from the rest of the bird family in the evolutionary tree?
Oh gosh, I'm just not qualified to answer that
Okay.
question.
I'll
But I
I'll, I'll
believe
get it.
that,
I'll put it up on the screen.
yeah, yeah, yeah. I mean, um, and again, I just want to go on record as that I have fought you all the way about this hierarchy and this ranking because it really is one of the really interesting things about studying animal cognition and animal societies is that there is no simple ranking. There is
Yes.
by many measures of complexity, every species has its own case to be made.
Yes. None of this just the disclaimers you're going to give now are going to temper the fires that are going on in the comment section right now.
I
Um,
don't think I'm even going to look.
so then birds, are we putting them into A or B?
M let's put them into, B.
And where do we think along the B? So with the one left to right being most complex, so the multi-male fusion
Put
fission
them
system.
right in the middle, just to the left of elephants.
Right. Okay.
You're forcing me to do stuff that I really shouldn't be doing, and I don't agree with.
That's what podcasts are for, no?
Yeah, right.
No, it's all educational. It's all entertaining, not meant to be taken as gospel in any way. But like I think even the explanations you've been able to give on each of these have been profoundly entertaining and educational and really interesting. We've gone through so many dynamics. And I think if anyone's going to take away anything, it's just shit's really complicated. Nature is absurdly complicated, and shy away from simplistic explanations because there's no doubt 1,000 other things going on in any society that you haven't accounted for. And even with all of the current research we have and all the amazing scientists, who knows what's going to be uncovered in the next 10 years, 20 years? Maybe this tier list flips on its head. Maybe the solitary rhino is somehow the most complex. We don't, unlikely, but you never know where this could go. I'm going to assume that we can safely put humans up at the S, and you're not going to have a major issue with that.
One of the things that's interestingly different from that separates humans is that we interact with strangers. So
Yes.
much of our daily life is interacting with people we've never met before. We don't know anything about them, and yet we've got to make do. And animals tend to interact with if not the exact same individuals all the time, certainly with a finite number of individuals. So, baboons, they live for 20 or 25 years with the same individuals, interacting with them over and over and over again. Every so often, a new male comes into the group, and so they've got to learn about him. But really, interacting with strangers is not a major part of their life. It
Yeah.
is for humans. And that means that we given the incredible importance of context in animal social interaction, particularly group living animals, we don't have that often in our interactions with humans. And that means that we've got to develop a whole set of analytical models that predict. I mean, if I'm going to interact with you, I don't know what you're going to do, and you don't know what I'm going to do. So I have to develop a theory that you will act in your own best interests, and you will develop a theory as well, and we will start testing that theory back and forth. That's really different.
Yes. Yeah, makes complete sense, and maybe not one that people would immediately point to. Really, really interesting. I'm going to give you a final chance to move around anything on this board. You can roughly see the position. I think you know where everything roughly ends. Are we going to lock this in and let the internet go insane with it? As last chance. Any final changes? But this has been just again like
No further comment except to disavow the whole hierarchy. I'm just covering myself.
No, it's amazing. This has been so much fun, Robert. It really has been such a pleasure. I'm sorry to make you so uncomfortable and having to do this, but I think it's a really fun format. I think people are going to enjoy it, and it's been such a pleasure speaking to you. I think you're an amazing educator, an amazing scientific communicator. Again, your knowledge, insanely encyclopedic knowledge of the animal kingdom, is so impressive, and it's been so fun to be able to pick your brain just a little bit. And I'm so thankful for it. Thank you so much. It's been great.
You're most welcome, and good luck to you.
If you made it this far, then you must at least partially be interested in brain science, and who can blame you? It is the most interesting topic in the world. Twice per week, I talk to the most amazing neuroscientists in the entire world, so if you're interested, then subscribe to the channel, leave a comment below who you'd like me to speak to next, and thank you so much for your ongoing support.